Okay, so now we have one circle and we have chords equal distance from the center. All right, so notice how, yes, ED is a chord, LM is a chord, and notice how these chords are equal distance from the center, which is point A. All right, so AC and AK are congruent. All right, we just marked that down here. AC and AK are congruent. What do you think is true about ED and LM? So what do you think about these actual chords? I'm going to just guess, kind of go with the theme. I'm going to go with congruent. And let's show ruler. All right, let's go over here. Show ruler. All right, whoa, they are congruent. They were both 41.2. So in fact, ED was congruent to LM. And it doesn't matter if I was able to move these chords around, which I'm not, but you could orient the chords this any way you want, but if they're equidistant to the center, the chords themselves have to be congruent. All right, so if two chords of a circle are congruent, if two chords of a circle, are congruent if and only if they are equidistant to the center. All right, so that's it. Actually it for the gizmos. Just knocked it out. All right, what we're going to just do now is start applying this stuff, just some problems, add some numbers. Basically the whole punchline of the first video and this video was things are congruent. All right, that's kind of the punchline. Now we're going to use that to come up with some new stuff. All right, or just apply them. All right, so if measure of arc CB is 100, all right, so arc is 100. All right, what is the measure of arc CD? All right, so we need this arc as a question mark. However, notice how CD and BD are congruent chords. All right, CD and CB are congruent. Thus, arc CD is congruent to arc. Oops, I meant to write BD right there. Brain fart. All right, thus, if I call this X, then this is also X. All right, and remember the whole circle adds up to 360. So all I'm going to do is say 100 plus X equals 360. 100 plus 2X equals 360. Subtract 100 from both sides. 2X equals 260. Divide both sides by 2, and X equals 130 degrees. All right, cool beans. The arcs or the chords were congruent, so the arcs were congruent. It gave us one arc, and yeah, just use some math. All right, same exact question but different. So notice how arc CD is congruent to arc CB. Thus, this arc is going to be congruent to this arc. Thus, that's also 176. So finding this bad boy right here, BD, we'll call that X, and all we are is going to have 176 plus 176 plus X equals 360 degrees. All right, and that's the punchline right there. And then you do 176 plus 176. I'm going to get 352 plus X equals 360. Subtract 352 from both sides. X equals 8. All right. Now what we got right here is, notice how this and this, all right, a chord, when the chord, maybe I forgot to mention this, maybe it was in the gizmo somewhere, chord perpendicular to diameter. Oops. If chord perpendicular to the diameter, then diameter bisects chord. All right, that means boom, boom, really quickly, x equals 6, and thus y is going to be 75. All right, so super easy problem, just things equal to each other. And that's kind of the whole punchline of today's notes. All right, and then again, we got chords that are equidistant to the center. Thus, the chords equal each other. Again, when in doubt, set things equal to each other. Probably find success. Divide both sides by 6, and then x equals 7. All right, the diameter of a circle is 25 centimeters, so let's write that down. Diameter is 25. Let me do a lowercase d for that. And the chord to the same circle is 16. All right, so we got to the nearest tenth. What is the distance from the chord to the center of a circle? Hint, sketch a picture. So this problem is actually really hard, but if we draw a picture and do some things, it will come together nicely. All right, so the diameter is 25. A chord is 16. All right, now there's a bunch of ways we can make this chord. Like, can the chord be like this? I don't know. Maybe we want to make it like this. I don't know. Maybe we make it like this. I don't know. All right, let's make it like, oops. Let's go ahead and make the chord like this. All right, now this chord is 16, and we want this perpendicular right there. All right, so using that fact we talked about, that means that's 8, and that's 8. All right, so what we want to find is this length right here. How close is it to the center? We'll call that x. Well, one thing I can do is draw this line right here. All right, oops. This is a radius, all right? All I do is draw a radius, and this is 12.5 because it's diameter divided by 2. All right, since the diameter is 25, we know the radius is 12.5. So all I did was set up a right triangle, boom. And now all I gotta do is use Pythagorean theorem, 8 squared plus x squared equals 12.5 squared, and I can find the value of x. And 56.25, subtract 64 from both sides, x squared equals 88.25. Take the square root of both sides, and x is approximately 9.4, right? So, again, drew a picture, diameter 25, drew the chord such that it was perpendicular, thus it was bisected 8, 8, then drew the radius, which we knew was 12.5, and used Pythagorean theorem to find how close the chord was to the center of a circle. All right, and then a quick slopes and lines review. All right, write the equation in slope-intercept form for the right to the line to the right. All right, so we have 0.2 and 0.3. Really quick, the rise over run was 3 over 2. All right, so some things to remember is slope is rise over run. It's 3 over 2. B, which is the y-intercept, it's where it crosses the y-axis, you can easily see is 3, just looking at the graph. Y equals mx plus b. All right, plugging in stuff right here, the slope was 3 over 2x plus 3. All right. So it says we need to graph a line parallel to the red line that passes through 3, -1. All right. Remember, parallel lines have equal slopes. All right. So my parallel slope is 3 over 2. All right, so 3, -1 is that point right here. Right 3, down 1. And then I'm just going to do a slope of 3 over 2. 1, 2, 3, 1, 2. Let me do a couple points. 1, 2, 3, 1, 2. All right, and boom. These two lines are, in fact, parallel. They will never, ever, 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 ever meet. And graph it perpendicular. All right. That means is opposite reciprocal. That means we change sign. That's what opposite means. Reciprocal means flip. All right, so my perpendicular slope change sign, it's going to be negative and then flip 2 over 3. So all I'm going to do is go at -5, 4, plot a point. From here, I'm going to go down 2 over 3. Nice, negative. Down 2 over 3. Nice, negative. All right. And this green line is perpendicular to the red and the purple line. All right. Cool beans.